Now we'll see about DR and BDR. See, DR and BDR concept, first of all, it will be used in a multi-access network. Okay. So let's say you have a router and you have you have a switch and some routers are connected to the switch. Let's say these are the routers connected to the switch. This is your switch, R1, R2, R3, R4, and R5. Correct? Okay. Now let's consider the IP addresses. Ten 001, 10.002, 10.003, 10.004, and this one is having 10.005. These are the IP addresses on the routers, right? So these same IP addresses, they will be the router ID also, right? So who will be elected as the DR? This will become the DR and this will become the DR. Correct? But the question is, why do we require DR and BDR? Right? Why we have this DR BDR concept? So if there is no DR BDR concept, what will happen? Understand? Who will become the neighbors for R1 and R1? If I configure OSPF, who will be the neighbors for R1?
1, 2, R3.
R2 also, R3 also, R4 also, and R5 also. For R2?
R1.
Correct. For R3? R1, R2, or R4? Correct. For R5? Correct. Now, if you remember, when we studied dynamic routing protocols, we said that whenever there is a change on any router, it will inform other routers also. It will inform its neighbors also, right? So let's consider that there is a new network added on R1. There is a new network added on R1. What your R1 is going to do? Going to inform. Correct. It will inform, let's say, network 1.1.1.1 has been added. So it is going to inform everyone. Means it will inform R2. Will also inform R3. Will also inform R4. Will also inform R4. Correct. Now, R2 received this information, right? R2 has received this information. So what your R2 is going to do? Also going to inform its own neighbors. Now, since the information has come from R1, it is not going to inform R1 again. Correct? Okay. Now, same information from R1 came to R3 as well. So R3 will inform Same information from R1 came to R4 also, right? So R4 will also inform its own neighbors. So R4 will send. Same information R5 also received from the R1. Correct. So R5 will also inform. This is just the case when they received the information from R1. But when R2 shared the information, again everyone received. Again they will inform. Same way, R4 also, R3 also, R5 also. So you can imagine how much amount of traffic is there just for one information. Just for one information, how much traffic will be there? And that's useless traffic, you can say, right? Because they will keep on exchanging, keep on exchanging, keep on exchanging. Okay, why? Because they will buy, in the default case, they will create full adjacencies with everyone, full neighborship with everyone. But to avoid these full adjacencies, to limit the number of these full adjacencies, what they will do? They will use the DR and BDR concept. They will use the DR and BDR concept to limit the number of full mesh adjacencies. To limit the number of full mesh adjacencies. If they will not create full adjacencies. So if you remember, in the init state, only hello is sent. Okay. In the two-way state, hello is sent as well as received. But also DR BDR action occurs at the two-way state, right? So if I can stop some routers at the two-way state only so that they can know that, okay, we are alive or not, then what will happen? If they are only at the two-way state, they are not going to the full state, the databases will not be exchanged. If the base will not exchange, they will not create what? Full mesh adjacency, because they will not have the information. Okay, so this is how it is done. Now what will happen? DR and BDR will be elected. How the DR will be elected? Highest priority or highest route ID. Okay, how the BDR will be elected? Second highest priority, second highest route ID. This is clear. Now, how will be the packet flow in case of if you have the DR and BDR? What the change will occur? Understand.
Everything after two-way, definitely DR, BDR.
Yes, definitely to a BDR. But again, that will depend on the type of network. In case of OSPF, this is not part of CCNA, but only in BMA and NBMA. BMA means broadcast multi-access. In these networks only, your DR BDR election will occur, and this will non-broadcast. NBMA, non-broadcast multi-access. Okay, in these two networks only, your DR BDR election will occur, and in case of OSPF, your by default network type is broadcast multi-access. You can check. Okay.
In the state after two-way state,
DR BDR election will occur, and from there, some of the routers will just stop at two-way state only, and remaining will go to the full state. That also we'll discuss, that who will go to the full and who will stay at the two-way. Okay.
So after BDR election, exactly.
Yes, after DR BDR election, first, once DR BDR election is happening, now master and slave election will happen to decide who will start the exchanging first, and then after the database exchange, then the loading state and full state. Okay. See. Show show IP OSPF. Interface. So you see here network type by default broadcast. Okay. So by default, your OSPF network type is BMA, broadcast multi-access. That's why DR BDR latch. And you see here, it is saying, what is the state of this router? DR. Okay. CCNP concept. CCNA, see, multi-area and all these things are available in the CCNP. Okay. Specifically mentioned single area OSPF version 2. Okay. There's a OSPF version 3 also that is supporting IPv6. Okay. Now, what will happen? See, once DR BDR election has happened. Okay. So these are known as DR. This is DR. This is BDR. Now the routers that are not DR, not BDR, they will be known as DR other. They will be known as DR other. One will be DR, one will be BDR, and remaining will be DR other. Okay. Now, how the neighborship will come? Your DR, okay, your DR with the BDR, it will create full adjacency. Okay. Your DR with the DR other will create full adjacency. Your BDR with the DR will create full adjacency. Because if DR is creating full with BDR, BDR will also create full on. Your BDR with the DR other will create full adjacency. Okay. And your DR other with another DR other will create only two-way adjacency. Means R1, R2, and R3, they will become neighbors, but only up till two-way street. They will not share full information with each other. Like R1 will not share the information with R2 and R3. R2 will not share the information with R1, R3. R3 will not share information with R1, R2. They will not exchange the databases. And why they are having the full adjacency with the DR and BDR? Because see, DR has to know everything. See now how the packet flow will be. Now, if any update is coming to R1, now since R1 is only DR other and it knows who is the DR and BDR, so it will send the information only to DR and BDR. Since it is not having full mesh adjacency with R2, R3, it will not share the information this side. Done. Now, remember the first slide when I said whenever the traffic is going only for DR and BDR, it will use the destination address as 224.0.0.6. Okay. Now, what will happen? These also should know, because in the topology, everybody should know that, okay, some change has happened. So that information will be given by DR. As long as your DR is available, your BDR will always remain silent. It will just receive the information. It will stay updated so that in case your DR goes down, it can take over the duties. But as long as your DR is available, it is not going to make any sort of decision. It is not going to forward any sort of packets. Okay. So what your DR is going to do? DR is going to flood this information inside the network. How? It will send this information to everyone. Also to R1, also to R2, also to R3, and also to R4. Now this information is going to everyone. So that means whenever the information is going to everyone in the OSPF, that will use the multicast address 224.0.0.5. Is that clear? Now, since the information has came from DR, every router is going to accept the information and they are not going to flood it anymore. So this is only the flow of packets will be there in case you have DR and BDR. Is that clear? Clear, right? Okay.
After time also, like DR can send traffic to BDR and also BDR.
Yes. Now why? Why they are able to send? Because
Sir, what is heading?
just 1 minute, please. Okay. Your DR and BDR, they listen on both the multicast addresses 224005 and 224006. Means they can communicate on both the multicast addresses, but your DR other, they are only listening to the 224005. They are not listening on the 224006. So whenever this traffic is coming on the address 224006, so these routers, they are not listening to this address. So even if the switch is forwarding the packets to them, they will drop the information because they are not listening to this address. Okay. But when the DR is sending the information, DR is sending to 224005. And all the routers, they will accept this information because all routers, if you see DR, BDR, and DR other, everyone is listening on the 224005. This is how the information will be flooded. Yes.
What is flooding, sir?
What is?
Flooding.
Flooding. Sending the information to everyone. So sending the information to everyone. Yes.
BDR will receive 2 times. Right?
Yes, BDR will receive 2 times. Okay. Since this is your BDR is listening on the 224005 also. So one time on the 224006, the information will come, and one time it will come on 224005. But still, as long as your DR is available, your BDR will remain silent. It is not going to flood the packet. In case your DR goes down, your BDR will take up the duties. Okay. Your BDR will change to DR and a new BDR will be elected. That will be your R3 because your R5 is down. Is that clear?
Sir, all data routers will not go for database software.
No, they will not exchange. They will remain in the two-way state only. And in the two-way state, they can only exchange the hello packets. Okay. And your hello packets, they are sent on the address 224005 only, not on the 6.
If DRO is down, sir, for example,
Yes.
router 2, so it will cascade the information to DR, R5.
If DR is down.
DR, R2, sir. DRO.
If R2 is down.
So it will
see, if R2 will be down, they will be sending the information. Hello packets are getting continuously sent, right? So all the routers, they will come to know that, okay, someone is down. So again, if someone, let's say R1 comes to know that this is down. So again, the information will be flooded only to DR and BDR. Okay. And then DR will flood the information to everyone. And they will follow the rules. I mean, the information that is given by the DR. Okay. Is that clear? Because every router, they are communicating. See, maybe, okay, fine, they are in the two-way state. But they are in the two-way state with these routers only. Still with the DR and BDR, they are in the full state. Right? So if they are coming to know that, okay, R2 is down. And even your R5 is also checking continuously. Because R5's full neighbor is what? All the routers. See here. DR with everyone will full. BDR with everyone will full. Correct?
It is like everyone has to report to the DR.
Yes. No. If there is a change on BDR, BDR is not going to send the information to DR. BDR will directly flood the information on the address 224005. Because it is also a designated router. So instead of sending the information to the DR, it will directly flood on 224005 and the information will get flooded to DR also and DR others also. But only when your DR other is sending the information, they will send the information on the address 224006. So that only DR and BDR come to me. Or else see, same thing you can see. I can say your DR with everyone is having the full adjacency. BDR with everyone is having the full adjacency. Correct? and your DR other. With the DR BDR, it is having full. And with DR other, having two-way. So you can only share the database with the ones you have full adjacency. You cannot share with the ones that is having two-way. So ultimately, the information will get delivered to only DR and BDR.
Suppose, that maybe like based on what you wrote, like everyone, if suddenly like both router 4 and router 5 completely goes down, then definitely it has to take a new election.
Yes. No, every time, even if the DR is down or the BDR is down, there will be an election. If the BDR is down, this will take up the BDR duties. If the DR is down, it will take up the DR duties, and this will take up the BDR duties. Okay.
So
Yes.
if DR goes down and after some time it goes up.
So again, it will not become the DR. Let's say, for example, your DR goes down. This became the DR, this became the BDR. Now this is coming back up. So it will automatically not become the DR. It will either manually configure it or either clear the OSPF process. The command will be clear IP OSPF process. Either give this command, or else if this DR is down, if this is down, then it will again become the DR. But by default, not automatic. Okay. Now this is all the backend process. You don't have to make any special configuration or calculation. Just all you have to do, connect the routers and switch like this. Okay. Do the normal OSPF configuration and you'll see automatically they will become DR and BDR. This is the automatic process. Okay.
Manually set also based on IP address, like we can
Based on the priority, we can change the priority and it will become the DR, because first preference will be given to the priority.
Yes.
And if you want that a router should never become the DR, just set the priority to 0. The router will not even take election in a part in the election of DR and BDR. Okay. One switch, and let's take 5 routers. 1, 2, 3, 4, 5. Okay, same topology will be same. Ten 001. Okay, same topology. Go to the notepad. Like this. Okay, this is R1. And also I'm going to configure OSPF here. Router OSPF 1. Network. Okay, area 0 we are considering here. This is clear. R2. R2. 10.0.0. R3. R3. 10.0.0. R4. Why?
Excuse me.
Yes.
So the IP address is class A, but you're giving subnet mask class 24.
So OSPF is a classless protocol, right? So supports your VLSM, CIDR, everything.
Okay.
Okay.
Hmm.
Now, one by one, just copy the configuration. Paste. R2. Done. Okay. So according to our calculation, this will become DR other. DR other. This will be DR other, BDR, and DR. Correct. And this will have on the DR, if we check, so we will have full adjacency with everyone, right? On that BDR, if we check, we will have full adjacency. So right now we are going to check on R1. Okay. So on R1, if I will check with here, it will have full. With BDR, full. With this, two-way. And then with the R3, two-way. Correct? Last check. Go to R1. We will check neighbor table. So if you see here itself, it is saying with 10.0.0.4, it is creating full. With 10.0.0.5, it is creating full. But for 10.0.0.2 and 3, we did not get any message here. We did not get the log, right? But still, let's go and check. Show IP OSPF neighbor. Check. With 10.0.0.2, two-way neighborship, and it is DRable. With 10.0.0.5, full neighborship, DR. 10.0.0.3, two-way, DR other. 10.0.0.4, full BDR. Correct? 10.0.0.4 is the BDR. 10.0.0.5 is the DR. Similar thing you will see everywhere on each and every router. See, only about 10.0.0.4 and 5. Correct? Here also you can check only about 4 and 5. But on the BDR, we will have for everyone 1, 2, 3, 4, 5. I mean 1, 2, 3, and 5. You see? 5, 3, 2, 1. Why? Because this is BDR. Similarly, on the DR, you will have 1, 2, 3, 4. Check. 1, 2, 3, and 4. Right? Correct? Okay. Now what we are going to do, we are going to add a network here. And we'll see whether it is giving on what destination IP address. Is it using 224.0.0.6 or 224.0.0.5? So this is a DR other. So whenever the information will add up or remove, means whenever there is a change, it will inform only DR and BDR. That means whenever DR and BDR are informed, 224.0.0.6. Okay. So what I'm going to do here, I'm going to add a loopback here. I'll say interface loopback 1, and I'll give the IP address. Let's say 1.1.1.1, and then IP address 255.255.255.0. Then I'll go to the router OSPF 1. I'll give the network 1.1.1.0, 0.0.0.255 and area 0. Before hitting enter, I'll go to the simulation mode so that we can see the packets. And right now I just want to see OSPF. Now, sir. Packet is generated. Open this packet. Who is the source? What is the destination IP address? 224.0.0.6. What kind of packet it is? Link state update. OSPF LSU packet. And LSU packet is used to give the information. Right? Now see. So this packet should go only to 5 and 6. I mean 4 and 5. See here. These will discard because they are not listening to the 224.0.0.6 and they are the DR others. Okay. And they will accept. Now, since they have accepted, as long as your DR is available, your BDR will not do anything. So it is not going to do anything. But your DR will do what? It will inform entire network. Correct. So if you see this packet, again OSPF, given by the DR, open this packet. Who is the source? What is the destination? 224.0.0.5. Because this DR will inform everyone in the network. And again, what kind of packet it is? So if I see on this packet, 224.0.0.6 packet, whatever the packet that came inside, and if I check in the packet details that what is the information, okay? So the information inside the packet is about the link ID what? 1111. About this particular network, okay? And the same information you will find in this packet because your DR will provide the same information to everyone. See? Okay. So this is how your DR will send this packet on the address 224.0.0.5. And since all the routers are listening on the address 224.0.0.5, everyone will accept this information. You see? And then this is what? This is the acknowledgement for receiving the information. OSPF acknowledgement. Okay.
In BDR as well?
Yes. BDR what?
So the packet we receive the 2 times. Right?
Yeah, receive. But as long as your DR is available, see, BDR will just remain silent. Why? Because whatever the information is traveling inside the network, whatever the changes are happening, your BDR will always stay ready and updated with the information so that as soon as your DR goes down, it can take up the duties. Okay. This is clear. Okay. So this is how your DR and BDR comes in. And if in case there is a change on DR or BDR, let's say on that there is a change on BDR. So BDR will not send the information to 224.0.0.6. It will send information directly to 224.0.0.5. Check interface loopback 1. IP address, let's say 4.4.4.4. Then router OSPF 1. Network 4.4.4. Go back to the simulation. Check. Directly update to the 224.0.0.5. Why? Because it is a BDR. So it will send to everyone. This information will be sent to everyone. And everyone will accept this information. Is that clear? So this is your DR and BDR concept. Okay. And if you want to change the priority, simple command I will tell you. Let's say you'll go to the interface Z0/0, because this is the interface you are performing the routing on, and you can say IP OSPF priority and whatever priority you want to give between 0 to 255. Okay. So if you give 0, the interface or the router will not take part in the DR/BDR collection. If you give 255, that is the highest priority. It will become the DR. Okay. This is clear. Now,
Happen in router 5?
yes.
Any changes happen in router 5 update?
Routers
5.
type.
5.
Router 5 priority.
No, router 5, any updates happen in router 5 means?
That will also go to 224.0.0.5 only.
Okay.
Okay. Because it is itself the DR, so why it will send to 224.0.0.6. Okay. Now let's say I want to make R1 as DR. Manually, I want to create R1 as DR. So let me go and just change the priority. So interface Z is 0 by 0. I'll say IP OSPF priority. Everyone is having 1. Let's say here I'll give 2. But by default, it will not become the DR. Okay. So for that, what you have to do now? You have to clear the OSPF process. Clear IP OSPF process. Done. Do you see? Full with 5, full with 4, full with 2, full with 3. Okay. Now just go and check. Show IP OSPF neighbor. One is DR, 4 become BDR, and these are DR numbers. This is how you can manipulate the DR and BDR action. Is that clear?
4 become BDR.
4 was already BDR. 5 was DR. So we changed the priority here to, you see here, and it became the DR. Clear? How you can manipulate the DR and BDR action. Is that clear? Any doubts?
So one is already elected as BDR, it doesn't change.
No. If only there is change for DR, DR will change. If there is change for BDR, BDR will change. Okay. Why it will change? Because see, highest priority. So this became the DR. Now in remaining of the routers, what happened? Only DR priority changed. I mean, this became the DR, right? So there will be no election for BDR. Only DR election. If BDR is down, election will be there for the BDR. This is how it is. Is that clear? Right?
First is priority, so only.
Yeah. See, there is no automatic change here. It is changed. If DR is down, change for DR. Look for DR. If BDR is down, look for BDR. That is it. Okay. So any doubts? No.
The first priority is they take first priority and then the router ID.
Yes, yes. We discussed that thing, right? Highest priority first and then highest router ID.
Okay.
PR election.
Sir, the command which your IP OSPF process, you have to use the command on
Where you change the priority.
This time down that R4 at you.
Okay, let's say if I turn out down the R4. Okay. So what I can do, I can interface the 0 by 0 and I can say shutdown. Now what will happen? There will be a new election for BDR. Okay, and who will become the BDR? Your R5. Check. With the R5, neighborship is full. So check. And you see it is already having the log also. See, neighbor 10004 down.
So this one is based on.
Yes, based on?
Highest router ID.
Yes, highest router ID. You see here, 5 became the BDR. Okay. Clear? Any more doubts? No. Online people? Any doubts?
So,
Okay. There's one more small concept about this is related to OSPF only, that what is LSDB and what is LSA. LSDB stands for link state database. Okay, so this is storing the information about all the routers and what all the networks are there. Okay, now this LSDB is storing the information in the form of LSAs. Okay, LSA is what? Your link state advertisements. Okay, so there are total 7 types of LSA in your OSPF. There are total 7 types of LSE. But since we are having only single area OSPF, according to single area OSPF, we have only 2 types. Okay, that is type 1 LSE, known as router LSE, and type 2 LSE, that is your network LSE. Okay, your type 1 LSE, it is generated by all the routers. It is generated by all the routers in the area. Okay. And since this is single area OSPF only, so it will be flooded inside an area only. So flooded within an area. It will never leave the area. And your type 2 LSE, it is generated by the DR. Generated by DR. And again, since this is single area OSPF, so this will flood it inside the area only. Will not leave the area within an area. These are the 2 types of LSEs. Okay. Now, on all the routers, your OSPF database will be same. Doesn't matter whether they are DR, BDR, or DRR. On all the routers, your OSPF database will be same only. Okay. So means if I'm checking the type 1 information, I will have information about R1, R2, R3, R4, R5. Because all the routers are generating this LSE. So in the type 1, I will have all the information. And type 2, it is generated only by the DR. And who is the DR? Only one DR, let's say, as of now in our network. So only one entry will be there. Okay. Is that clear? Now let's go and check the databases. I'll show you. See, let me do one thing. Let me change the priority back to 1. And let me keep the default keys here. Will be easy to understand. Interface the 0 by 0, IP OSPF priority 1. Okay. And then also bring this to 1. No shutdown. Okay. And let's change clear the IP OSPF process. Clear IP OSPF process. Okay. Again, go to R1 and check. Show IP OSPF neighbor. Now, sometimes you'll face this kind of problem like R3 is becoming the BDR. Okay, so what you have to do, go to the R3 and clear the OSPF process. So that recalculation will happen. Clear IP OSPF process. Check again. Now correct. 5 is DR and 4 is BDR. Now if I check the OSPF database, show IP OSPF database. See, this is R1. R1 is a DR other. So if you see, this is the OSPF database. In this first type is router link state, means type 1 LSA, router LSA. Okay. In this, it is generated by all the routers, right? So you see entry about all the routers, R1, R2, R3, R4, and R5. And the network link state, network LSA, generated only by the BDR. So this is having generated only by the DR. Okay, so it is having only the DR IP address. Okay, so this is how the database it is. Okay, is that clear?